This lesson is part 2 of parallel lines and proofs involving parallel lines. In this proof, we want to prove that if a quadrilateral is a parallelogram, then consecutive angles are equal in measure. When we have it written as an if-then statement, the if part, if a quadrilateral is a parallelogram, is considered the given statement. The then, the conclusion part, consecutive angles are supplementary, is the prove part. Now let's start out by drawing a parallelogram so that we have a picture to work with. And what we want to do is label all the sides with lines. We're going to call this line M and this line N, M and N, and then this line is going to be T and this line is going to be R. So we know M is parallel to N because it's a parallelogram, and we know R is parallel to T by definition of a parallelogram. We want to prove that consecutive angles are supplementary. So we're going to want to prove that angle 1 is supplementary to angle 2, and that angle 1 is also supplementary to angle 4. That way we know consecutive angles are supplementary. So angle 1 is supplementary to angle 2, and angle 1 is supplementary to angle 4. Let's start out with the given. M is parallel to N, and R is parallel to T. That's our given. Now because M and N are parallel, and we see that they're cut by this transversal T, angles 1 and 2 are on the same side of the transversal, and they're in between the two parallel lines. So they're co-interior angles. And co-interior angles are supplementary. So we can say angle 1 and angle 2 are co-interior angles. You can't read that, co-interior angles. And we can also say angle 1 and angle 4 are also co-interior angles. Those are quotation marks. Those are just copies. Because here we have a transversal and T is parallel to R, so 1 and 4 are also on the same side of the transversal, so they're also co-interior by the definition of co-interior angles. Then we can say angle 1 is supplementary to angle 2, and angle 1 is supplementary to angle 4, because parallel lines implies that co-interior angles are supplementary. This is an abbreviation that I'm using. You can write out the whole theorem, which is on your postulates page, and it's this one right here. If two parallel lines are intersected by a transversal, then co-interior angles are supplementary. That's what we're using. And so we've proved that consecutive angles are supplementary because they're co-interior angles. Here's our last proof we're going to do on this section. We're given that line M is parallel to line N, and we want to prove angle 3 is equal to angle 4. Well, let's start with our given. M is parallel to N, and that's given. And then we want to look at what we know. We know that these are parallel lines, and we want to try to find a way to tie angle 3 to angle 4. Well, 4 and 1 are vertical angles, so we know that they're equal in measure. Can we tie angle 1 to angle 3? Well, they're on the same side of the transversal, and they're both above their lines, so that means that they're corresponding angles. And since the lines are parallel, we know that corresponding angles are equal in measure. And then if we know that 3 is equal to 1 and 4 is equal to 1, they must be equal to each other. So that's our plan. That's how we're going to go about proving it. And we need to just be careful with our steps. So we're going to start out by saying the measure of angle 1 is equal to the measure of angle 4 by the vertical angle theorem. Sometimes books have you state that they're vertical angles by definition before you use the vertical angle theorem, and that's fine. You don't need to do it, but if you add it in there, that's okay too. We also know that the measure of angle 1 is equal to the measure of angle 3 because parallel lines implies that corresponding angles are equal in measure. That's this top one here. If two parallel lines are intersected by a transversal, then corresponding angles are equal in measure. And then when you have two different angles equal to the same angle, substitution says that those angles are equal to each other. Measure of angle 3 is equal to the measure of angle 4 by substitution. That's it.